Hello everyone, April the 2nd. Alright, so the goal today is let's finish this and we have to check the good solutions for this one because I do not like the solution I had yesterday that much. And if we still have time, maybe we can take a look at this. Alright, boats to save people. You are given an array people where people I is the weight of the ith person and an infinite number of boats where each boat can carry a maximum weight of limit. Each boat carries at most 2 people at the same time. At most 2 people, provided the sum of the weight of those people is the most limited to the minimum number of boats to carry every given person. Huh. Okay. Five times 10 to the 4, okay? So we want to know the so 2 people at most, right? And the limit is 3, so it's still like a 2-sum kind of problem. So we'll start with sorting. Always we sort people, right? Have some small to large, and 2 people. So for what if it's not possible? No, people I is small equal to limit, so it's always possible. So can we say that the best is always going to be the largest value have to partner with the smallest value? I don't think so. I think it's the largest. I think we need to fit, right, as close to limit as possible, which means we go from large to small. Then the largest we need to find on a small which one is the closest to it. Yeah, because we want to take as many people. We want to take 2 people at a time, right? And if we can, we do it. If we cannot, like the heaviest person is just too close to limit, we cannot, and then those people have to go by themselves. And if you can take someone, it will always be better to take someone with as high as possible, because if you take it a lower, then it might be that in the future you cannot take those 2 at the same time. Yeah, so basically we want a heavy person, right? And then limit minus the heavy person will be the largest possible. And then we can binary search, right? To find the value, the largest value that's smaller to this, which we'll be able to find. And we'll take that, right? We'll take that. Now, the issue is once we take that, we need to remove that value because we have to keep doing this. That does not seem well. I don't think we need to do that. How about 2 pointers? We have one at the end, okay? And the other one we just move forward until we hit the first one that the sum is smaller or equal to limit. And we will do that. But what if nothing is? So we keep moving, so it's too big, nothing. And now we move to the next one. No, that's So how about we move from small to large? Now small to large also doesn't work. You can go all the way to the end. And next one will be bigger. Oh, 2 pointers start from both sides. So we have the smallest and we have the biggest. And if the sum is larger than, we need to move to the left. The right pointer move to the left, right, until a point where the sum is smaller or equal to, right? And then the low move forward. So if this is smaller or equal to, which means we add more will be bigger. So if on the left side we move forward, then we can keep going. Right? If it's too big, then we just move down. So we'll do this, and we keep moving, and all the others, they have to go by themselves. All right, so we have this and this. Too big, this has to go by itself. Too big, this good, so we do it. And then move in. If it's too big, go by itself. And we move in, it's good. Then we keep moving until at the end, if too big, move by itself. Let's try. I'm not 100% sure, but I don't have a good proof for that, honestly. So this is what I think, right? We sort people, right? And then we have a low, high, and then rest equals 0. So while low is smaller than high, if people low plus people high is larger than limit, right, then rest plus equal 1 and high minus equal 1. Else rest plus equal 1, low plus equal 1, high minus equal 1. Which means what we can do is this, we can do high minus equal 1 here, right? And low plus equal 1, and then blah 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 blah. Eventually, okay, low might be plus equal 1. So if this is good, then when we get out, say if low is equal to high, that means high move down. That person has not gone yet. Then rest will plus equal 1. Then we return rest. Okay, let's give this a shot. Does this count as greedy? I do think this is greedy, right? This will be 1. This is 3. And this is 4. Yeah, I think this counts as greedy. People limit rescue people limit. Yeah, it works here, but not 100% sure. You wanna, yeah, we can do some test cases, simple test cases like this. I still need 1 bolt, right? Let's give this a shot. See if it works. It works. So this is the 3rd time, right? The 3rd time we do this. Not too bad. Okay, so this is, yeah, I think this is greedy. Greedy. Sort people, right? The ideal is that the pair must have as close a total weight to limit as possible. This means for each low weight person, he must pair with as heavy a high weight person as possible. Using 2 pointers, right? We can move the right pointer down until people low plus people high is smaller or equal to the limit. That is a pair. That is a valid then we move low and high both towards the center. If the sum is larger than limit, then the high weight person must take the boat by himself. Okay, so let's take a look at the solution. Greedy 2 pointers. Why is this so simple? I can do smaller equal to. Answer plus equal 1. Oh god, yes. Oh, probably NP hard. So this can be simplified. Yeah. Simplified implementation. Same thing. But this one can come out, right? So this is gone, which means it's just small equal to, right? And then we can say equal to. Then it doesn't really matter, and it's just plus 1, so we can remove this one as well. Yeah, I don't think we need to submit this one. Okay, so this one's done. Let's go take a look at the solution. 32 and hash. That's exactly what we did, right? Hash map. Oh my god. Oh, solution 1 TLE. Yeah, that's what I tried. So they build this hash map first. So it's the same idea. I built it along the way. But they just start. They just build, right? That's a good part. If this is larger than 2, that's actually an easier way to build it. What should give TLE? Oh, yeah. Ah, they have this kind of tricky part. So it does not, I do not have this issue because for me, I don't build it from the start. I build it along the way. I find this, I get its length, right? And then if it has not been checked for the length, I check it, right? I check it and I have the window and I use sliding window to check it. It's slightly complicated, but I don't have to worry about doing this kind of thing, right? I do this, I get it, but this is tricky, right? This is tricky. Start and have to redo it here. Otherwise, we have the left strip exactly, and we have this map to say if it's larger than this. If it is, we reset it, and we cut this. Yeah, then this is the part, and then we say this one checked, and avoid the rechecking, and then we just do this. Oh, it's actually not that bad. Okay. All right, let's take a look at this one. Subsequence with the minimum score. Given two strings, S and T, you're allowed to remove any number of characters from the string T. Any number of characters from string T. The score of the string is 0 if no characters are removed from string T. Otherwise, let left be the minimum index among all removed characters, right? Between maximum index among all removed characters. Then the score of the string is right minus left plus 1, just the length. The minimum possible score to make T a holy crap, sequence of S. Okay, so we are allowed to remove any number of characters, right? And the score of string is 0 if no character is removed, which means if T is already a subsequence of S. But if it's not, then we need to remove some stuff, right? We have the right and the left, and the score is the distance between the two. So in the first one, I have BZAA. So we have to move Z for sure. And after remove Z, we have BAA, right? And we definitely have B, we have A and A, so we only need to remove Z. Oh, 1. If we remove 1, it's always 1. 1 minus 1 plus 1. Oh, now X, Y, Z have to remove all of them because empty is a subsequence. God damn. So that's 0, 2 minus 0 plus 1. Holy crap. Oof. Okay. So we have something to remove, right? And then we want to know subsequence. How do we check if a string is a subsequence of another string? That's a good question. I have no idea. And of course, the fewer you remove. Wait, is that true? The fewer you remove, the better it's gonna be. So would it be possible you remove more and then if let's say you remove more, it can make it into a subsequence. I have no clue. Oh man. We can use counter to identify any letter in T that does not exist in S. So they have to be removed. This is the easy part. But the difficult part is the order of the remaining letters, right? And let's say I already have something removed, so I know the minimum, the largest at the moment. If the remaining removal happens in between, you have to realize that it does not really matter how much you remove. What matters is the maximum distance between the edges of the removal. Therefore, if you have something to remove, you should do that. Those are like definitely needed. And hold on. I was thinking maybe given T, right? I remove everything. That's our base. And I starting putting things back, right? And to put things back, we have to go both sides because that is the best way to reduce to reduce the score. So I say I put the left and right back. I just put one back. It's the same, right? So we put the left back. Is it possible? And say the left is in it. Okay, so it's possible. And then we try to put the rightmost back. And I say, okay, rightmost back. Is that possible? I say, okay, it's possible. Because we do have that. The smallest is this. We try to match. So the smallest matching will be this. Smaller matching of that will be that. Okay, so we set the tone. And then we put, because moving towards the center, and we'll find this. And say, is this possible? Right? Is this possible? And we find the letter, and then we find the smallest of that, and see if it's possible. If it's possible, we put it. If that's possible, so we can just keep moving in, right? Keep moving in until we cannot, right? Until we cannot. So what happens if you cannot keep moving in? Well, what happens is if at a certain point, like if a value just does not exist, then that's gonna be. Then we just need to consider on the other side. We try to push on the other side as far as possible, because on one side, if on one side we have impossible, then that's just a hole. There's no way we can deal with it. So if everybody else is trying as left as possible and as right as possible, so they shall all be the ideal situation, and you have one and it's not possible, right? It's just like its occurrence is all outside the range and you cannot do. If that happens, you can either fit that, and you have to destroy everything you've done already, which actually will make the score higher. This might work. It's a greedy solution, and I am more than happy to try it. Let's try this greedy solution. So what I'm thinking about is, right, we all count. It's actually not counter. Default dict, right? I need to know default dict. I need to know the indices of every single letter here, from small to large. So for I letter in enumerate S, we will do letter index, okay, equals default dict list. I would say letter index letter dot append I. Ooh, dot append I. that is actually not what we want. I want it to be, holy crap, I want it to be on both sides, so I can pop left and pop right. Yeah, pop left and pop right. So why don't we use a deck? Holy crap. Yeah, we still append. That's fine, right? We append everything. And then for T, we'll delete every single thing, okay? We delete every single thing. And then we have a low and a high. Low is 0, high is len, T minus 1, okay? So that's that. And we just say, if it fits, right? And we just say while low is smaller than high, okay? Low is smaller than high. Maybe it should be smaller or equal to. Yeah, maybe it should be smaller or equal to. Right? Then what do we say? We say if low fit. If fit, we'll move forward. Okay? What do we say? We say T low, right? And then if hold on. What will be the ideal way of doing this? If I know the previous, right? The previous. So I know I can keep moving. So I need a pre on the left side shall equal to, let's do -1, and pre and post right, let's do line s. Okay, so we shall say T low is this letter, and then letter index, right, dot get. Okay, if it does not exist, I want to do a mass.inf. Does that make sense? And the 0. So that will be the smallest, right? So this is the smallest index that will fit T low on S. So if this is larger than, right? If this is larger than pre-left, if this is larger than pre-left, then we can take it. All right, then we can take it. Maybe I should just go two times. Go left to right, because we want to fit as much as possible until we hit something that we cannot hit. Yeah, it doesn't really matter like doing at the same time. We just go left to right and then go right to left. Well, I mean, it's fine. We can do this. Then it has to be negative, right? Negative. So we'll get this. If it does not exist, then it'll be negative. So it will definitely not be possible. So if it is larger than, then we can say pre-left will equal to, oh, hold on. Let's do what? Let's do minimum left index, okay, will equal to this, right? That's the minimum left index. And we say if minimum left index is larger than pre-left, then pre-left equals minimum left index. That is correct. And then we'll say this T low dot pop left. We need to get rid of it. Okay, and low can plus equal 1. Else, if it's larger than, This is smaller. If the minimum is smaller then we don't do anything. The low just stay where it is. Low stay where it is. Okay, low stay where it is. Then how do you know when to jump out? When low and high has not moved, both got stuck. Okay, if both got stuck, then that's it. But how do you know both get stuck? We can say here, low stuck equals high stuck equals false. Okay. Well, this and not low stuck and not high stuck. Right? Then if one of them, actually no, and this, one of them, as long as one of them is not stuck. If not low stuck or not high stuck, we'll just keep going, right? Otherwise, we can say else low stuck is true. Okay? Then we do the same thing for the high. Okay, we do the same thing for the high. So it will be the max right index is equal to this down, and then again this. That will be high, right? And we say if max right index is smaller than post right, then it's possible. Then we say post right will equal to max right this, and this will be pop, and then high will be minus equal 1. Otherwise, high will get stuck. Right, will be stuck. And then we'll keep doing this until it jump out. Right, until it jump out. Now when it jumps out, then we can handle low and high, right? Because we want to score. Then we say that is the smallest low and high. Then we can just do return high minus low plus 1, because these must be removed. There's no possibility that they can stay. Okay, does it make sense? Should be 1. There should be 3. This will be interesting. It shall work based on the logic. Okay, ST minimum score ST. Pop from empty. Holy crap. Yeah. But how? Because it's a low, it's supposed to be high. The first one's not right. How come? Gordy. Nothing changed. Huh? Wait, what? This is bizarre. Huh? So I got 1, 2, okay. Wait, hold a second. 1 and 2. 1 and 2. Oh, let's do it at the front. It's confusing. All right, that's more like it. Okie dokie. So we start from 0 and 3, right? And 0 is B is good. So I say B, 1 gets popped. And 3 is A, so A gets popped. That's good, right? So B will be picking out this, A will be picking out this. Next one is 1, 2. So that's 1, and that's 2. And 1, it got stuck, right? 1 got stuck. And high shall still be able to go because it's A. High shall be 4. 4 is still available, right? 4 is still available. So high shall still be able to go. But why, when you go out, high, they say is not available. 0 and 2 is A, right? High, A. A. Oh, that's not 0. Dude, that's a -1. Plus, I just realized one thing, right? So this has to be larger than the pre-left, but it has to be smaller. It has to be smaller than post-right. It has to be in between. If it's coming all the way to the right, then it's also not going to be good. So it has to be pre-left smaller than this and smaller than post-right, right? Whatever we want has to be in this range, and this is the same. It has to be pre-left smaller than this. This is more likely, okay? All right, we're gonna run it. If it fails, we will have to think about it later. Yeah, it's, I don't know, I'm not sure. Just randomly put something in there. Okay. This is usually, I think, it's the most likely test case that we'll do. I don't know, just randomly bash something into it and then see. Ooh. Okay, so this is not right. Damn it. Can we have a easier test case? Digging is out of, oh, there's so many issues. There's so many issues. Holy crap. Can we have even more? Man. A, B, B, A. How about this? B, B, A, B, B. I don't know. How about this one? Dear God. Oh my God, come on. Give me some. Give me some. Okay, so now we have an issue. That's pretty good. Answer shall be, oh Jesus, 0. B, B, A, B, A, B, E, S. And I said 2. Okay, that's very wrong. That is very wrong. Come on. Let's see. Low, high. Let's do it on top. Let's do this. Low, high, and low, high is 4T. And then we have let index. Okay. So 0, 5, 1, 4, 2, 3. And 2, 3 we say that's bad. 0, 1, 2, 3. 2, 3 is AB, right? Now we have AB. A and B. Huh? A and B. The thing we can choose, A we have these to choose from. B we have these to choose from. So for A, we probably also need to use pre-left and post-right. Okay, pre-left is 3, post-right is 8. So we need to find something that's A. It's really small, okay? A small A that's larger than 3. We can do 5. 0, 1, 2, 3, 4, 5. Yeah, we can do 5. And for B, we can do 9. Oh, we can actually check for 7. We thought about that. Yeah, we can check for 7. I see. We can check for 7. So it shall be a search until we exhaust. Okay. So so if T low is in let index, while let index T low and let index T low 0, okay, is smaller than pre-left, right? If it's smaller than pre-left, then what do? We want something bigger, right? Then we just say let index T low dot pop left, or pop until it gets out, right? Now when it gets out, I want the thing, right? And we just say if let index T low then, so if it's smaller than, we pop out until it's larger than, right? So we will say if this is T low, then we do this will equal to T low, right? T low dot pop left one more time, right? We pop this one out. We don't pop it out because we might not use it. So we get this and we say if this is also smaller than post right, then we will do this. Okay, which I think this I can do, put it here, and we say if and this is smaller than post right, then this will equal to this will equal to this pop left, and the low plus equal 1. Okay, else low got stuck. Either we don't have or low got stuck. And we do exactly the same thing for the other side. So we will just come up. All right, and we say while dear Lord, left, right. So we say this is now low, all the low has to be high. Okay. Well, this and this minus 1 is larger than post right and the pop. Right, while this and this minus 1 is larger than pre-left, we say post right equals this pop, high minus equal 1. Otherwise, high stuck is true. So it'll be something like this. Does this one work? This one work now. How about these? They all work. Okay, I think this is a good change. Fixed a few issues. We should have... doesn't matter. We all do the same thing. At least I'm pretty sure that it's not possible to have, you know, something like out of... Oh my god. Okay, I think we got stuck. If we got stuck, it's easy to do. We'll be just, we'll think about it another time. But let's see. I hope we have a... Oh my god, both are wrong. Holy crap. Holy crap. Man, this one's tough. This one is tough. Okay, so the smallest test case passed, but the other two does not pass. Okay, this one's good enough. Yeah, let's take all three of them. Let's take all three of them. Dear Lord. This one is tough. Okay, this one's 3. This one we got it right. This one we did not get it right. This one is wrong. It's too big. Kind of don't want to handle this one. Expected 6. You know what? Yeah, I should submit it. Otherwise, it will be an illusion that we got this one right in one try. Expect is 1. Yeah. Okay. Hold on. All right, I'm gonna do one more round, and then if it doesn't work, then we call it. Okay, this should be 1, which means we just remove one of them. Okay, BA, that's fine. And we have BA, no, I want BA. Oh yeah, this is BAB, and the rest is the same. This and BA. So it's BAB, this is ABA. So I can just remove this, right? I remove this, or I remove this, doesn't matter. How is this one not right? So again, I try from, and then this idea doesn't work, right? I try from the outside. If I abandon this, then I already work. But I say I want to fit this. And the only way to fit this is to get this A, okay? Then we can have this B. Then this A. Then I will go to this A. Then B, A, B. Then we have something else. Yep, this one's not working. Alright, I'll think about it. Something to think of before going to bed. Yeah, I still think, I mean, look at this. The size is 10 to the 5, okay? DP feels, I don't know. I don't think DP feels right. Greedy, but this greedy also doesn't work. Binary search. We'll see. All right, that's it. That's it for today. I'll see you guys tomorrow. Adios.